Hello, this is Miss McLean, and this is a quick little video about the basics of z-scores. So z-scores are used for normalcy. We have to have a normal distribution in order to be able to use z-scores. Here's your z-score formula. So in order to find a z-score, we need a data item, we need the mean, and we need standard deviation. Here's a formula that's also on your formula sheet to where if you were asked to find the data item, you still need the mean, you still need standard deviation, and you also need z-score, okay? In order to use your tables, you have to have a z-score, right? So when it comes to your table, if they don't give you a z-score, you have to first find your z-score, and then you can look up the probability in your table, okay? Let's talk about the symmetric and total being 1, okay? So the total area of this entire curve is 1 or 100%. Now the values in our table are decimals, but we can easily change those decimals to percentages, okay? So again, total is 1. We do have a symmetric graph here, a symmetric picture, to where if I cut this in half and fold it over, it is the same thing, okay? I do want to talk a little bit more about symmetric when it comes to z-scores and your tables. So let's say we have a z-score of negative 1.5, okay? So I'm going to go ahead and look that up in my tables. So negative 1.5 is right here, 0.0668. So that tells me the area to the left is 0.0668. Okay. Now, if I look up my z-score for 1.5, 1.5 is 0.9332. Again, your table always gives you area to the left, right? This is everything to the left, right? Now, since we do have symmetry, if I wanted the area to the right of z-score of negative 1.5, I have options, okay? So my two options are I can take the area to the left right here and I can subtract it from 1. I want you to notice what's going to happen if I subtract from 1. So notice in my calculator, we're getting the exact same decimal for the opposite z-score value. Okay, so we got the exact same decimal for the area as its opposite z-score value. And the reason why is because it's symmetric. So everything to the left here, notice I'm missing this right chunk, and guess what that right chunk is? It's this value right here, okay? And again, it's because it's symmetric, right? So you've got two different ways that you can work out when you are asked for more than a value, okay? Now I'm going to go ahead and briefly go over each one of these areas because you're going to be asked to find those areas. So first up is less than, okay? So if you are asked to find less than a particular score, so let's say the mean is 10, and let's say your data item is 8, and you are asked to find the area or the probability less than 8. That is going to come straight from your table. Now, in order to use my table, though, I have to turn 8 into a z-score. So I would plug into my formula, get my z-score, look it up on the table, and grab that area, okay? Now, of course, I can't do that for this particular problem because I didn't tell you what the mean and standard deviation is, okay? They're going to give you that information. Up next is when they ask you for more than. Now, more than could be greater than, it could be the top percent, and so forth. So more than means we want the right side. So let's say I want more than 8. So to get the more than portion, we are going to once again change 8 into a z-score, look that up on our table, and we're going to subtract that value from 1. Right, so I'm going to put 1 minus the number you get from your table. So if I subtract this, I'm going to get the right side. Now, I previously just talked about symmetry. So let's say our z-score wind up being negative 1.5. Well, instead of doing the 1 minus, you can forget about that. You can just look up the z-score of 1.5, and it's going to give you the same result. Let's talk about our last case, which is between. Again, I'm just kind of making up some values here. Let's say we want the area between these two data items. Right, so in order to do this, keep in mind that our table always gives us the area to the left. Okay, so if I change my 8 and 12 into z-scores and look them up on the table, it's going to give me some areas. Okay, so let's say I look up the area in the table, right? I want to subtract these two areas because if I take this left side chunk away, notice it's going to leave me with the shaded region. We don't have to worry about the right side in this case. So again, I'm going to take these two areas and subtract. And when I do that, it's going to leave me with that in between area. Now keep in mind, you always want to do the bigger area first. So the bigger area minus the smaller one, because when we're solving for areas, and probabilities, our answers are always positive. Okay, so that's a quick rundown of z-scores and finding areas. So hopefully you find this video useful. If you've got any further questions, feel free to contact me.